better at the NSF style than the DARPA style. So let's all practice doing the DARPA style instead of the NSF style. So you pair up and have 2 minutes where you explain the broader impact of your research and then the science. So 2 minutes for that, and then switch and have the other person explain the 2 minutes of the broader impact and then the science. Any questions on that? Clear? Okay, go. So done and swap. experience. Any observations? Yes?
It's hard.
It's hard.
Yeah.
What was hard about it?
It's hard to make it simple and compact while not,
Yeah, it's hard to make it simple and compact without losing the important pieces. Is that what you said?
right, without feeling like you're not doing justice to the vision.
Without losing, doing justice to the vision. Yeah, okay. Go ahead. Again?
I think sometimes it's hard to convince the person that the problem that you're talking about is actually a problem, because it might feel like more problem to you, but for them, why do they even care?
Yeah, it's hard to. Can people hear him, or should I repeat him? Repeat it, yeah. So he said it can be hard to convince the person you're talking to that the problem that you're working on is actually a problem that they should care about. Is that right? Yep, okay. Other comments? Yep.
I find it kind of interesting thinking about what the impact is based on going forward into the world, because I guess often I think about the impact of we will have these new tools, but maybe that's not really the real world impact. So even trying to put impact first, I mean, like, I don't know what the impact is necessarily.
Yeah. So you're saying it's hard to, the impact is we'll have these new tools, but you're not sure that that's actually the real impact. So thinking through what the impact actually will be is challenging.
Yeah, and maybe that varies for different audiences.
And the impact can vary for different audiences, yeah. Yeah. Close person, and then
It's hard to be precise.
it's very hard to be concise, yes.
Even in this situation, it's hard to know what your audience is without asking, especially if you're not asking questions. It's hard to know if you're over or under explaining.
It's very hard to know what your audience is, even in this context where you know a lot about your audience, without asking questions. Yep. Yeah. Those are all really good observations. It is something that you can get better at with practice, and I think the comment about the questions is a really good one. I think in general, in many situations, feedback loops are really, really valuable, and so if you're doing this in a context where you can actually ask questions, that can be super valuable because you can get feedback, and then you can change what you're saying based on the reaction. And you can also get feedback from body language as well without just explicit questions. If somebody's like looking like they're not paying attention, or their body language is kind of turned off, or they're looking bored, then you're like, oh, okay, not pitching it the right way. Let me redo this. I find that large language models can be good practice because you can tell them to pretend to be, act like you're X, and then you can interact with the language models and get some feedback. Yeah. Other questions, comments, or observations? Yep.
Sort of a comment, but I feel like the analogy of where does the rubber hit the road can help when you're trying to answer a Darpa question. Like, I remember in a philosophy class, one thing that we talked about was like, what are the practical implications of the philosophical debate? And I think just the rubber hits the road, like metaphor, really helps me try to like ground the things I'm working on.
Yeah, I think that's a really good observation. The comment was like, where does the rubber hit the road? What are the real practical implications can help focus your thinking in the impact space instead of in the science space? At DARPA, when we create programs, we have to think both about like, what's the technical hypothesis? What's the technical piece that you're trying to solve? And then, so like, when you create a DARPA program, there's like, what's the 10-year vision? What's the problem you're trying to solve? What's the world we're trying to create? What's the technical hypothesis that we have that we think the science can, we may or may be able to do it, but the technical hypothesis, that we think it might be possible to prove this technical hypothesis that would make that 10-year vision possible. And then what's the impact maximization strategy? Like, what do we have to do once we've proven the technical hypothesis, or assume the technical hypothesis is proven? Then what do we have to do to actually make that 10-year vision realized? Because it's not enough to just prove the technical hypothesis. That's just sitting in a lab somewhere. But you have to actually, to change the world, you have to change people's minds and to change their behavior. So do you have to like start a company? Do you have to change standards? Do you have to change policy? Do you have to go, create a whole bunch of open source software and get a whole bunch of 5-star reviews on GitHub? Like, what do you actually have to do to change that world? And that's a lot of the rubber hitting the road. And to think about all those things and convince a whole lot of people. So like that, again, that's like the impact maximization. Yep.
Program managers
you're asking, can program managers contribute to their own programs? So DARPA program managers are kind of like the way a program manager at DARPA works is more like the way a professor manages their own research group. It's very much more hands-on than what you would think of as an NSF program director. So an NSF program director is more like kind of a referee, where the call goes out in NSF land and proposals get submitted, and then a panel comes and ranks all the proposals, and the NSF program director kind of makes sure that everything happens fairly. And then the NSF program director gets to kind of interleave the various panels, and so they can have their own interleaving process. The program manager at DARPA is the one who's responsible for the creation of the program in the first place. They're the ones who make the case that DARPA should be creating this program. And so they're the one who has to go to Tech Council at DARPA and pitch the concept of the program. And so the whole formulation of the program is their idea, more or less. And when the proposals come in, they lead the selection process. They do get evaluations from other experts that basically say whether the proposal is selectable or not. But then they make the case based on those reviews to the source review officer, who, like right now, I'm the source review officer for I2O, to say, like, these are the proposals that we want to fund. And that process is, it's unlike like reviewing for a conference or something, because like you as the program manager have basically gone to the agency and said, like, I think we can solve this amazing problem for national security with this technical hypothesis. And now you review these proposals, and like these proposals are the raw material from which you can either succeed in what you've promised the agency might be possible, or you're going to fail if you don't get the right proposal. So you're very, very invested in making the best choice possible amongst the proposals that are submitted. And then you make that selection. The source review officer says yes or no, or Tink usually says yes. And then the contracting officers go and negotiate with the organizations to put those the selected proposals under contract. And then you kick off. And then the program manager is responsible for overseeing the research of all those organizations and tracking progress. Are those organizations following through on what they said? Are they making progress towards the technical hypotheses? Are they working towards the metrics? Going back to DARPA and saying, yes, we're tracking towards the metrics that I promised you we would be tracking towards, or no, the metrics aren't the right metrics, or no, they're failing on the metrics. Teams that don't make their metrics or that are failing for various reasons get cut. Other teams might get added in. The whole program might get canceled if the program is overtaken by events, or if the overall process isn't good enough. So the program manager is intimately connected to and in charge of that program. It's probably much more of an answer than you expected, but yeah, they're very, very connected. And that is, all of that engagement is partly why communication skills are so important, right? That program manager has to clearly make the case for that program. They have to write the broad agency announcement that has to communicate clearly to the whole community why the problem is so important. They have to communicate to the head of the agency, who is not a computer scientist, why this problem is super important. They may have to defend to congressional staffers. Like I couldn't give 2 lectures today. On Monday, I couldn't communicate to staffers. My deputy had to communicate to staffers why our programs had to be couldn't be canceled, basically. So like there's a whole range of different kinds of communication that has to happen as a program manager. Written forms, verbal forms, etc. So yeah, communication is a super important skill. Other comments, questions about this exercise, this experience? We'll have a time for a little bit more questions in a bit. Brings me to my one more point about communication. Communication is not just formal writing and formal verbal communication, it's also networking and socializing. Even though most computer scientists are introverts, networking and cocktail party kind of conversation is still really important. It's also a skill that can be learned. So like this book that's on the bottom, How to Know a Person, The Art of Seeing Other People Deeply by David Brooks, is an example of a book that can teach people how to network, not just with your friends, right? Communicating with your friends is easy, but like when you get dumped into a networking event where you don't know all the people already, how do you talk to those people and have a good conversation, which is something that like I've had to work on because it's totally not my favorite thing. And one of the like super simple examples is don't ask fact questions. Like if you ask questions that are like you just give a yes or no answer, or you give a fact-based question, the conversation just goes boop. But if you ask meaning and value kinds of questions, then people start engaging and opening up, and then you can have actually a really interesting, engaging question that can go on for a long time, and you can learn interesting things about those people. And when you have a real connection with those people, that's when you start to be able to get interesting long-term connections that can help you in terms of getting long-term business connections or research connections that can help in other ways. So for example, don't ask, where did you grow up? Ask, what did you like about where you grew up? Or what did you dislike about where you grew up? Or what did it mean to you where you grew up? Because that opens the door to find out all sorts of interesting things about the person that you wouldn't find out just like, oh, I grew up in San Marino. Like, what does it mean that I grew up in San Marino? Like, you don't know what San Marino is. That doesn't mean anything to you, right? But like, I grew up in a town where like, I thought I was middle class. I didn't find out until I went to Stanford that I grew up in a rich family. Like, I didn't know that, and that made that's why I became a computer scientist, more or less, because I took intro computer science because I had a super powerful computer, and I was embarrassed about having such a super powerful computer and not knowing how to do anything about it except write papers. And so I took intro computer science and discovered that I really loved it, right? You find out more about a person when you ask a question that allows them to open up and tell you more about it than just, where did you grow up? Yeah, question.
Just saying this is an instruction manual for talking to people.
Yes, actually, it is an instruction manual for how to talk to people. And it's actually a really easy book to read or listen to. And it starts from like super shallow conversations that you can have at the grocery store into really deep conversations about like somebody who might be, thinking about suicide. And it's in examples, where the examples are all super interesting, and it's very actionable. So yeah, I've read that book multiple times at this point. So it's the premise of that particular book is part of what's wrong with society today is that we've forgotten how to talk to each other. And David Brooks wrote the book in the hopes that people could learn how to talk to each other in a non-shallow way. And that's just an example. And I think that there's a lot of truth to that. And I found like part of the reason why I really don't like cocktail parties is that I feel like the conversations are super shallow. Like, what restaurants do you like or something like that. And that's really boring to me. But the questions that he talks about in that book get you to have much more interesting conversations. So since I've read that book, when I go to cocktail parties, it's way more interesting. So like not only is it like helpful professionally, but like cocktail parties are way less boring now. And then the last lessons learned is like leadership skills. So our field views leadership skills like with visceral knee-jerk suspicion. And I think that's just really stupid. And we should get over this. And I think maybe it's because people think leadership skills mean like people want to be bosses of other people. And that's just like, totally the wrong way to think about leadership skills. Leadership skills don't mean one person being a boss of another person and telling other people what to do. Good leadership, that's not what good leadership is. That's bad leadership. So like having a visceral negative reaction to bad leadership, 100% fine. Have a bad visceral reaction to bad leadership. But developing as a field, good leadership will allow us as a field to just accomplish so much more. I mean, part of good leadership is being able to run a meeting that starts on time and ends on time and accomplishes a lot of stuff instead of having everybody just sit around and not accomplish anything, right? With good leadership skills, we could write collective grant applications much more effectively, much more efficiently. Our team meetings could be much more effective. We could be able to write grants as an organization much more effectively. We could have our departments be able to convince the deans to do stuff instead of having other departments have their be able to convince the deans much more effectively. So we should just be collectively much more interested in good leadership skills. And just like communication skills, good leadership skills can and should be learned. It's never too early to start. Volunteer organizations are a really good place to practice leadership skills because basically volunteer organizations are willing to put people in charge when they're super early in their career because they're desperate. So basically the picture there, like leadership skills give you a really long lever arm. You can accomplish way, way more with a group of people than you can by yourself. And some of my leadership principles, like be trustworthy, right? If you're not trustworthy, people aren't going to trust you with doing more, like working on your behalf or working with you. So being not being Machiavellian is just not a good way of being a leader. And treating everyone with respect, right? There are people in academia who have power because they bring in a lot of money, and they exercise that, they demonstrate that they have that power by being a jerk and by getting away with being a jerk. What they don't realize is that they don't get other stuff because of that. They don't see that they don't get other stuff because they don't know that they're not getting other stuff. But people who have power and who are a nice person get all the stuff that they get because they have the power, and they get other stuff because they're a nice person. So, like, yes, you can get away with being a jerk in academia if you bring in a lot of money, but you lose other stuff that you don't know that you're losing. And just being a person who treats everyone with respect is just that's a huge win. And that's one aspect of that, is meetings starting on time and ending on time. Another aspect of that is when you are a leader who has responsibility to give in hard feedback, giving that hard feedback when it's called for in a compassionate but clear way is a way of treating people with respect. Choosing to duck giving people hard feedback is not treating them with respect, because it's a sign of disrespect to not give people hard feedback. It's saying that they can't handle the hard feedback. It's denying them the chance to learn from the hard feedback that they should be getting. There's studies that show that when you need to give hard feedback, the person who's supposed to give the hard feedback often shies away and doesn't give the hard feedback, or gives it in such a shallow way that the person doesn't hear it. And also the person who's supposed to be hearing the hard feedback doesn't hear the hard feedback either. So it's really, really hard to give hard feedback. But it's really, really important. If you don't give the hard feedback, the person can't learn that they're doing something that needs to be improved. So this is something that I've strived really hard on, worked really hard on. It's not easy. And then, one of the most important things is having that closed feedback loop, because if you have a feedback loop, in terms of, in my organization at I2O, having a way for people to pass information back up the hierarchy about how things are going so that we can improve. Otherwise, if you do something wrong and nobody can tell you did anything wrong, then there's no way to prevent mistakes from becoming catastrophes. So having if there's no way to sort of tell truth to power, then things can just spiral out of control really, really fast. So closed feedback loops are really, really important, which is probably advice for when you're much more senior in your career. But thinking about ways to make sure that you have feedback loops in all aspects of your life is really, really important. And I think with that, I will just let you ask me questions. I think we just have a few more minutes here.
Do you have an example of a hard feedback that's delivered compassionately?
Yeah, let me think about that. Well, I think the compassion is part of the tone of voice and the understanding, and that it's the person, they're not a bad person. That understanding how the thing they did or the pattern of behavior is not okay, but they're still valuable as a person. That you want to work with them to develop the skills to not go into that situation again. And listening is really important too, to understand, to hear them out. I think that those are some of the pieces. While clearly communicating that whatever it was not acceptable, not okay. Hearing out, I think, hearing out what they thought was going on and why they were there. So listening and making sure that they understand that you hear where they were coming from. So, hearing that, reiterating that I understand the circumstances that led to this or that's leading to this. Not okay. Let's talk about how to give you the skills to have a different outcome the next time.
I was only asking if nobody else has a question, possible long answer if she chooses to answer it. I was going to say, it might be helpful for everybody at home, because you asked that when the exercise you asked at home are communication, the Hellmeyer catechism.
Yeah.
I always thought like when DARPA talk would be like almost complete without it, so I don't know.
See.
Time.
Sure.
Okay.
So the question is, what is the Heilmeyer Catechism, and how does it, what is its role at DARPA? Yeah. So I mentioned that program managers are responsible for starting programs at DARPA, which is true. And the way that program managers start programs at DARPA is by answering the Heilmeyer Catechism questions. The Heilmeyer Catechism questions are named after George Heilmeyer, who was the director of DARPA, I think in the 70s. And it was in response to a kerfuffle between him and another DARPA director whose name I will remember, but not right this second, who wanted, George Heilmeyer wanted rigor, and he won. The first Heilmeyer, and my job right now, my job as an office director is mentoring program managers through this process of putting together program pitches for new programs at DARPA. So I spend a lot of time iterating with program managers on answering the Heilmeyer Catechism questions. So the first Heilmeyer Catechism question is, what are you trying to do with absolutely no jargon? And you need to answer this question in about a paragraph, 2 paragraphs. You should be able to answer it in like a minute or 2 minutes of time. And it's the vision for what you're trying to do. And by the time you finish answering this question, your audience should be like, oh, that's a really big problem. We really should be trying to answer this question. So when I was a program manager, I started the Hackins program, which was about using formal methods to produce software for automobiles and other Internet of Things kinds of, that would make it so that they couldn't be hacked. So the answer to the first Heilmeyer Catechism question was trying to produce software for vehicles that would make it so that they could not be remotely hacked. And right, which is like, before that, work from Yoshi Kono and Stefan Savage showed that you could remotely hack into an automobile and take over control remotely. So I was like, yeah, we kind of want to make it so you can't remotely hack into an automobile and take over control remotely, because that would be bad. And automobiles are symptoms of lots of, or symptoms are representative of lots of kinds of systems that are, you can connect to them remotely and you can take over control, and they're physical systems, so they can affect the physical world. The second Heilmeyer Catechism question is, how is it done today? So that's like the related work question. And part of the question is, if DARPA does nothing, what will happen? So DARPA has like a $3 billion a year budget, which sounds like a lot of money, but there are a ton of really important problems. So this question is sort of like, does DARPA really need to solve this very important problem, or is somebody else already going to solve this very important problem? So a lot of my office, one of the main thrust areas in my office is AI, right? AI is like super important right now, but it's moving super fast. Silicon Valley is doing a ton of stuff. Like, so can we just let Silicon Valley go off on its own? Is it going to solve all the problems, or is it not going to solve all the problems? So this is a super important question right now. Like the H2, is Silicon Valley going to solve it already, or do we need to do something, is one of these really important questions right now. H3 is, what's your idea? What's your technical hypothesis? Why is now an important idea at time? And what's the basis of confidence? So basically, what is your technical hypothesis, and why do you think it might possibly be true? So, like, transporter technology from Star Trek. It's really easy to answer the rest of the Heilmeyer Catechism questions for transporter technology, except there's no basis of confidence. No one has any idea how to build transporter technology. In fact, it's pretty clear from the laws of physics that we can't build transporter technology. So that's the H3 question. The H4 question is, who will care? And right now that's being interpreted a lot as the impact maximization strategy. So assume your technical hypothesis has already been proven. How are you going to make your 10-year vision come to fruition? What's your strategy for, assuming your technical hypothesis is true, for getting it out into the real world? So do you need to start companies? Do you need to go change standards? Do you need to go get a program of record to use it? Like, what's the strategy for getting it used? And then H5 is how are you going to measure your progress? What's your program structure? Things like that. And how much is it going to cost? Things like that. So to start a program, you have to have really, really good answers to all of those questions. The questions sound completely straightforward. Answering them well is really, really, really hard. And program managers often, like to answer them well, they go out and talk to lots of people in the community, professors, people in companies, to get really hard data-driven answers to those questions. So it's often the case that when a BAA comes out, lots of people in the community already know that the program is coming out because the program manager has gone to talk to people in the community before it comes out. Question?
So what if the recent areas we've heard about is this exponentiating mathematics?
Yep, that's a program in my office. Pat Chapto.
So one of the things that kind of aligns with what you're talking about with these criteria is there's some specifically addressing this in the TA1 automation versus TA2 evaluation, but there's kind of this effect, especially out of the industry, particularly for these AI formalization, there's a bit of disconnect between evaluation and what is actually happening with these AI tools for producing foreign code. Some charitable view of it is misleading to just not as careful as evaluation. Can you talk a little bit about how this